All right, mathletes, on this lovely day, we're going to do two things. Number one, we're going to evaluate algebraic expressions. Number two, we're going to simplify algebraic expressions. So before we jump into that, we do need to know a few properties that we already use. You've used these all your life probably, but now we're just going to put names to them. All right, so numero uno, the first one here, the definition of subtraction. The definition of subtraction. Subtraction means to add the opposite. That is all subtraction means. So let's see here. If you have a minus b, that's the same as saying a plus a negative b. Why is that important? Why do we care? Because remember the properties we looked at yesterday. You cannot commute this without consequences. You can't commute it because it's a negative, it's a minus. You can't commute it. However, can you commute with the plus sign there? Yay! You can commute it. So if you wanted to commute these, you could break a law, or you can convert it and then commute it. So it does work. Our next one here, our definition of division. So if you all remember this, KFC, yum. Ew. Keep it the same. F, flip it. And C is to change it. KFC, keep, flip, change. Keep, flip, change. Division simply means to multiply by the reciprocal, or KFC. Reciprocal. Spelling is important. So notice that B is actually B over 1. So when you flip that, you get 1 over B. Keep the A, flip the second one, and change it. KFC. Next, distributive property. Turns out the distributive property also applies when you have subtraction. Notice here, I have subtraction inside there, and all I have to do is send the A in. Already done. Let's skip down to multiplication by 0. This is the great equalizer. 0 times a number is 0. Multiplying by 0 gets 0. All right, the next thing here. This one's muy importante. Muy importante. All right, the opposite of a sum. So let's see what's happening. Inside the parentheses, we're adding two things together, and we take the opposite. Why is that important? And you're like, well, it's the same as adding opposites. It's the same as adding opposites. Now, when is this important? Well, take a gander at this. I'm actually going to go the other way around. Most of us do not enjoy adding negatives together. We say -8 plus -15, and we're like, it's on the wrong side of the 0. I can't figure this one out. Here's the shortcut. Pretend they're both positive. And drop a negative on it. That's the super secret shortcut. So we all can do 8 plus 15, that's 23. So you drop a negative on it, -23. That's what that rule is saying. That's a negative times. Oh no. It's not times, right? It's adding. Plus a negative. Right. So in this case, the opposite of a sum is the same as adding the opposites. Or if you're adding two negatives, it's the same as adding the positives. Just drop a negative on it. Okay. So this one here, when the opposite of a product, it's just like saying it's the opposite of one of the factors. Opposite of one of the factors, and then multiply out. Okay, these ones seem unimportant to you, but they are rather important. Whenever you multiply by a -1, you get an opposite. This is called the oppositifier. I made that word up. It's the oppositifier. If you want to take the opposite, multiply by -1. Technically, divide by -1 is lo mismo. Okay. No, this one's a made-up word. You're never going to see this. I'm going to say it a lot just because I think it's an important, like it sounds good to me. Makes me sound really intelligent. says today we're going to take out the oppositifier. Okay, the opposite of a difference. Please circle this. Please highlight this. Please learn to spell. That would be me learning to spell. Thank you very much. Okay, this is muy importante. Muy importante. All right, you might not think it's important, but let's take for a second of what is happening here. Okay, number one, we start off with a difference, a minus b. So the opposite of a difference is the same as saying b minus a. So what does it feel like to you? What's kind of happening here? They're switching, but do they only switch and nothing else? No, if you were to switch, in other words, if you were to commute around the negative, you have to take the opposite. We'll show you in a second why that's important. In fact, let's do it now. What if I had this? 8 minus 39. Most of us do not like to take away more than we have, right? So what's the shortcut? You flip them, but drop a negative in the front. It's kind of like the commutative property of subtraction, except you have to attach a negative. So that's what it's saying, is that when you're dealing with subtraction, if it's too complicated, just flip them to get 31 and drop a negative on it. Negative 31. So like I said, it's like a commutative property of subtraction. Lastly, the opposite of an opposite is a positive. The opposite of an opposite is positive. Learn to spell. It would be so good if I learned to spell. Positive. Is that 2 S's or 1? No, it's 1. Where we left off yesterday was me learning how to spell, right? So positive is actually 1 S. Okay, so the opposite of an opposite will always give you, in this, a positive answer. Double negative is how we also say that. Okay. Let's chat real quick about some of these terms in algebra. So let's attack, kill, destroy, evaluating an expression with exponents. So we're asked to evaluate this expression, k minus 18 squared minus 4k, when k is 6. So let's walk through the steps and then have you practice. Step number 1 is to take my 6 and substitute it appropriately. So I'm going to substitute it in, and I'm going to use good habits of using a parenthesis every time.
Why do you think the parentheses?
Good. Why do we have to? Sometimes you don't have to. But it's best, or when you don't know, just do it.
So what if it's alone like this?
So over here, we did substitution. So make sure that we are writing that in. So my first thing I can do right here is I'm going to switch these two in my head, 18 minus 6, and attach a negative to it. So 18 minus 6 is 12. I attach a negative to it. I'm going to bring down the square. And so I multiply the 4 times 6 to get 24. So what two things did I do over here? You could write that you did the grouping in the red. You could also argue that you commuted the subtraction, like we did the opposite of a difference. And in blue, what did we do? We multiplied. You could also say I simplified, and that's fine too. Bar, we are now going to square. Negative 12 times negative 12 is 144. Now I bring down the 24. And the only thing there I did was evaluate the square. So you can write down square, you could write down multiplication. Both would be a sufficient explanation for your step. And the very last thing to do is to just subtract. And there's no special thing we did there. All right, let's take a gander at this next one. As a reminder, as you look at math problems like this ugly beast, too often we look at it and we say, I don't get it. And then we stop. That gives me an excuse to stop because I don't understand it. We don't have to understand where that comes from, but we can use it. So here's the situation. Let's read through this. Follow along as I read. The expression negative 0.08y squared plus 3y models the percent increase of voters in a town from 1990 to the year 2000. In the expression, y represents the number of years since 1990. So 1990 is actually year 0. So 91 is year 1. Find the approximate percent of increase of voters. All right, so how do we manage this? Well, since we're looking for 1998, we just subtract that from our year 0, and we get 8. So 1998 would be year 8. And now we just take our variable and we can substitute it in. So I'm going to copy down my super secret formula here, which I have no clue where that came from, but I'm going to substitute in the ocho instead. So step number 1, we substitute.
Is that a 2 next to the parentheses?
Go ahead and write our next step. I'm going to bring down the coefficient here, which does not change, but the 8 squared, according to my order of operations, becomes 64. And I can actually carry down and multiply out as I go. So what 2 things did I do here? In the red, I evaluated the exponent. And then in the black, I evaluated the multiplication. And because they're separated by a plus sign there, I can treat them independently. So here I multiplied first to get negative 5.12, and then I combined those two to get 18.88% increase. So how do I interpret that? I could say something like this. Since 1990, there has been almost a 19% increase in voters. The last thing that we want you to learn about today is not just evaluating like terms, but we're going to combine like terms. Now, I'm going to do something funny on A. I'm going to spend so much time combining like terms in such a weird way that you're going to say, I never want to do this. But of course, there's a shortcut. Okay, so let's go step by blinking step of what's happening here. Okay, step number 1. So my first step is to distribute. So I use the distributive property to distribute the 7. How it works. All right, so our next micro step says this. I'm going to switch these around because I want my h's together. So I bring the 2h here. Now I add the 14h, and now I'm going to write the negative 3k and bring down the 21, the negative 21k. So what property did I just use? I commuted. So I use the commutative property there. Next, I'm going to associate things together, and I'm going to rewrite that as in a single step. I'm going to associate these two together, and then I'm going to associate these two together. Pay attention to the double negative that happens there. I did change this from a minus to a plus because I pulled out a negative from both of these terms. That's what there is there. So what did I do there? That's the associative property, technically. All right, going on, now I can technically do the distributive property, but I won't explain it. I'm just going to say adding things together, right? So here I get 16h, and over here I get 24k with a subtraction in between. So what did I do over here? I combined like terms, added those together. Now what's the shortcut? Of course we want a shortcut. At this stage, we can just start focusing on the things that are the same. The 2h combines with the positive 14h to get 16h. Next, the negative 3k combines with the negative 21k to get negative 24k, which of course is what I got down here, 16h minus 24k. Feel free to do either one, the super long way, or just kind of circle or underline the things that are the same and bring them together. The key, of course, to pay attention to, notice you have to bring the minus as a negative. The minus 21k can be interpreted as a negative 21k. Pay attention to like terms. Be very, very close. Pay attention. That like terms is something specific. There are two things. Same variable and same exponent. If after we combine our like terms, the purple all here are like terms because the x squared, and x squared there to get negative 3x squared. And lastly, 5x plus 1x is 6x.